everyone. In this, we will understand about crashing of project network. In any project network, the first thing is that we'll draw the network diagram and then we'll determine the critical path based on the normal activity timings. Then after we do this, we see whether any activities can be expedited, means whether we can able to speed up those activities by adding some additional resources to the work. In many situations, we may be interested in finding the least possible project completion time if crashing of activities is permitted. We'll see now what are the various terminologies used in crashing. First one is about crash limit. It is the difference between the normal time and the crash time. For example, if the normal time is 8 days and crash time is say 5 days, then our crash limit is 3 days. It means that particular activity maximum what you can crash is, what you can reduce is 3 days only. So while crashing a particular activity, there is a lower limit beyond which it is not possible to reduce its time anymore. Normal time is the time taken to execute an activity under normal circumstances. Crash time is the minimum duration of an activity beyond which it is not possible to reduce it anymore. In our example, we considered 8 days as normal time and 5 days as crash time. So below 5 days, you can't able to reduce it. And the limit is nothing but the 8 minus 5, which is 3 days is the limit. The cost associated with the normal time is called normal cost, and the cost associated with crash time is called crash cost. Generally, it is quite obvious that normal time will be more than crash time, and crash cost will be larger than normal cost. So this will be the time cost relationship. X-axis we keep time and Y-axis we keep the cost. Since the crash time is lesser, it will come in the beginning itself. Normal time is more than the crash time, it will come after that in X-axis. Whereas in Y-axis, if you look into, normal cost is lesser, whereas crash cost is more. So normal cost come near to 0 and crash cost is exceeding your normal cost. And the change in cost over change in time, you call it as a slope. So here the slope is calculated as normal time minus crash time divided by crash cost minus normal cost. So you crash the project until it becomes uneconomical. The slope of crashing an activity means the incremental cost expediting that activity per unit period. The crashing of a network increases the direct cost because you are going to add resources, etc. And you are trying to speed up the activity, but it results in reduced project completion time, which will in turn reduces the indirect cost also. So we try to take a trade-off between the direct and indirect cost when a project is crashed. We will see with the numerical example, how do we actually do a crashing in our next video. Thank you.